Hey, David, thank you for coming in. You've done a lot. You've really an outstanding background of contribution and accomplishment and just really making sure that you have such a positive impact to the world across so many different dimensions. And I know my audience will love what you're doing and what you've done in the past. So again, thank you for coming in.
Yeah, absolutely. Thanks for having me. I really appreciate it. I don't feel like I've had a major impact. I've been sort of blessed to have so many technical experiences and things that set me up to be able to work on problems that have meaning for me, which is a luxury, I think. Finding a purpose where you can align your technical passions with an impact on the world.
Well, you definitely are that. There's just so many different examples, and I'm really looking forward to mining some of that background and getting your context and your passions and so on. Now, you've got this amazing career; it's continuing. So there's got to be 2 to 3 inflection points in your life. It probably scores more, and maybe it was when you're 3 or 5 or 10. It could be inside, outside the family, in school, outside school, career milestones, things that really shape you to who you are today.
Yeah, no, I think that's absolutely right. I probably the greatest inflection point from finding my passion and then being really, really lucky about that passion when it arrived in time and then in the business world as well. So my dad was in the military and we were stationed in Barstow, California. Barstow, California is in the middle of the high desert, halfway between Vegas and Los Angeles. It's not known as the best place on the planet. About 60 miles outside of it, in the middle of the desert, really nowhere, is a military base called Fort Irwin. And my father was stationed there. It's where they run war games for the Army on Russian tactics in the desert versus U.S. tactics. Regardless, this was in the early 80s. They used a ton of, well, at the time, which was fairly novel computing technology. And my father got to have a PC that he brought home for work. And so I remember it was an Altos. It had a CPM operating system and ran DOS sort of on the side. And I heard about this game. I think I was like 8 or 9, and I'm reading these manuals trying to figure out this stuff. And the inflection point was when I first got a game running on the Altos, and I'm sort of exploring this cave through text, and my imagination is just exploding, and I was just hooked. I was hooked. It was like, this is the most amazing thing ever. And then through a series of, great opportunities in my life, I've basically been able to time PC explosion, computer software, with the wave of the internet and the rest of all the goodies that we're now experiencing. So for me, that moment was fundamental in defining everything about my career.
Yeah, that's amazing. I mean, I recall CPM 86, and you had these early kind of CMOS processors, the 8088, but before that, the 6502, and then the 8086 came out, or approximately the same time, and then you got into 286 series, but and there was like DOS 1.0. Which was originally QDOS, right? Quick and dirty DOS. Actually, Microsoft did come up with the first DOS. It was somebody else, right? So.
No, I didn't know that. And that's what's been also so amazing is like my worldview as a kid. It was like it was a manual and it was a computer, and I didn't know where it came from. I saw this Timex Sinclair thing come out. There were all these TI 99.4A. There were all these little home computer experiences. I was just like, okay, I don't know what these things are. I don't know what these businesses are. And it's been amazing for me, the unraveling of the complexity of the entire ecosystem that you were talking about keeps expanding. You have all of these brilliant people across all of these different fields from silicon to software. And I'm just a kid going, oh, look, I can play a game. It was wonderful. Yeah, the diversity of it, the timing of it, for me, it was wonderful.
Yeah, and then in those early days, there was kind of like minimal abstraction. I mean, you had to actually build your own drivers. And if you did anything outside of CPM 86 or DOS 1.0 or some of the other stuff that was out there, you had to build it yourself.
Yeah, I remember there was one of these, I can't remember which when it was, it may have been an early Apple, you had to sort of write your own keyboard driver.
Yeah.
It's like, okay, and, kids today, they don't know how good they have it. And sort of it's this worry of, creator versus user, and what is the right mix of how deep to dive into these technologies.
Yeah, or programming in raw machine code and then assembler was like a miracle. And then you get into higher level languages, and that's even like, oh my God, so much easier, right? So
And that triggers me because that's probably the second inflection point that's fundamental to my career arc and where the company I'm running today is I went to school at Texas A&M here in Texas, which is where I'm based out of and have been forever. And I interned at a company called National Instruments, which is based in Austin, which is where I now live. And National Instruments had, some brilliant founders. And, there's a guy, Jeff Kadowski, who's one of the founders of National Instruments, and he created, along with the team, a small team, LabVIEW. And so you may not have heard of LabVIEW, but there's this term now that floats around the VC communities that is about these abstractions and software that you're talking about called low code and no code methodologies. And Jeff created the world's best, and I think first and still probably best, and now oldest maybe, low code abstraction for graphical programming of computers. And it uses a concept called homogeneous tokenized data flow. And it's just a brilliant implementation. And that was my first taste of how do you keep abstracting away the complexities of these cyber physical systems so that you have more and more capability, leaving the power and flexibility, but trying to add ease of use and accessibility. And it's like a constant battle. And so this idea of what is the sweet spot of the abstraction for letting someone who's not an expert use a system like an expert, it is this constant tension that you see across so many fields. It's what I'm trying to solve in life sciences with artificial, but I see it trying to be solved everywhere. How do I automate and deal with variability and complexity, but make it easy so that people not trained in automation and programming can deal with it? And then that triggers, and how does AI help us do that?
So let's mine your career arc just a little bit more. I mean, you got your Bachelor of Science in Computer Engineering from Texas A&M, which you mentioned, and in 2011, relatively recently, you were recognized by the Texas Academy of Medicine and Engineering for technology innovation. You hold 42 patents. So clearly, there's kind of roots with your father instilling this dream and curiosity continued. And then you mentioned, being part of National Instruments. In fact, you were the VP of software R&D, right, at National Instruments, and you worked on a lot of stuff, and including, CERN, Hadron Collider. Everybody knows about that amazing center just out of Geneva, and then SpaceX ground control. Can you talk a little bit more about that transition from computer engineering in your academic studies to National Instruments, and then working on these amazing sort of programs that are so, or platforms that are so well known?
Yeah, no, I think, and that's why I mentioned NI as such a strong inflection point. The other founder of that company, Dr. Truchard, he had an amazing ability to build a very structured sandbox around new employees where I felt like I had so much room to create and innovate, but really I was in a box doing what I was supposed to be doing, but I felt empowered to just do amazing things. Now, National Instruments is a platform company, and they make hardware that really is about actuating or measuring the real world. So any kind of sensor that you want to read at any kind of speed, ranging from telecommunication signals at massive speeds of acquisition to, slow moving temperature and strain and motion and physical properties and things like that. So it has all these hardware building blocks, and then it has the aforementioned low code tooling around it so that, scientists and engineers who are not embedded systems experts or measurement control system experts or control experts could take these bag of goodies and building blocks and really build anything that you can imagine dealing with the cyber physical world. And so that means that you have this massively horizontal platform play, a mixture of hardware that does I/O of various kinds, and then software tools that lets non-experts program it. And that's how National Instruments got into selling to such a broad base of solutions like ground control at SpaceX, because I like the CERN Hadron Collider is a better example. It's like, where, if you're a scientist sitting there, in Lucerne or wherever, and you're like, hey, I need to build a Hadron Collider. Like, you look up in the yellow pages or search the internet, where's my Hadron Collider builders, right? They don't exist. And so you just need to find smart scientists and engineers that can use these tools. And the tools need to be easy enough, because you do run into this like 3 PhD problem or this domain expert problem of the physicist who understands the nature of what the Hadron Collider needs to do is in and of himself in this massively complex domain that's super deep. And they need a team of, hard real-time control experts that know how to synchronize when a magnetic pulse shoots across a fast-moving beam to keep it from hitting a wall. Like, those are very different problems, but they're all in support of each other. And if I bridge that forward to where I am with the company I have in life sciences, which is called Artificial, it's the same problem. I have these amazing customers who are PhD research scientists looking at, massively new concepts around cell and gene therapy, or like Moderna doing mRNA therapeutics. They need to automate things. And they're masters of their domain. They're amazing. They know life sciences and the human body and cells and therapies way better than anything I could ever conceptualize. But they need to automate and control the physical world, in this case, small volumes of liquid and other sorts of things, at a very precise level. And so this mixture of domains and tools to abstract, you talk about the themes, I really look at my time at National Instruments is learning how to build platforms that abstract complexity to the real world for users of various capabilities who are deeper in their own domains. And probably the quintessential, most approachable example of that, which I and many, many people at National Instruments had the opportunity to work on, was partnering with Lego to build Lego Mindstorms. And so it to me is the poster child of, here is a robotic programming solution that's really approachable. It's flexible. It solves a surprisingly deep amount of robotics problems. And it's used to program a kid's toy.
Yep.
And under the covers, it is LabVIEW, abstracted one layer further than it normally is. And that LabVIEW is used by SpaceX and is used by CERN. And so kids programming robots are using the same methodologies to do these insanely complex systems with one layer of abstraction removed. And I find that concept really, really powerful. And so for me, abstractions that hold and don't leak and express ease of use as you build them up, they're the pillars on which we've technologically built everything. And so when you find one and it lands, people may not notice it, but it's a beautiful enabling thing.
Yeah, but it also inspires and creates passion. It's just like if you talk to the astronauts, many of them who are old enough and remember the original Star Trek series, they were inspired by that series to dream and think anything is possible. But you've done that with the Lego Mindstorm. Really, it would inspire millions of youth to say, hey, I can do a career in imagination, creativity, and leveraging technology. So you've had that same, like, sort of being a catalytic sort of inspiration for generations with your Lego Mindstorm work and your other work like Star Trek yet. So I could see kind of the parallel. But then you end up then at CTO of Kuka, right? In fact, I just finished judging the Innovation Factory for AI for Good, and one of the judges is actually from Kuka.
That's
It's a small world, right?
That's a truth. It is a massively small world that in technological circles, and particularly also robotics is teeny tiny, really at the end of the day. Yeah, no, that would probably be the next major inflection point. I mean, I basically spent a life at National Instruments. I worked there from age 18 to 43. That company had rock solid technical marketing and sales foundations. It was a great place. Um, you know, more or less, I reached an inflection point after a life there of like, am I going to be the CEO or not? as things go along, and more or less, I came to the unfortunate conclusion that I don't think I'm going to be the CEO of National Instruments. So I answered one and only one headhunter call that I've ever. I mean, I've been there forever. I weathered the internet. I never left. I worked in this domain. It was my thing. And I met this great person who had like an extremely high EQ mixed with a high IQ, and totally different than the leadership at NI. Much more financial background, not a deep technologist, but an intuition for technology. His name's Till Reuter. He was the then CEO of Kuka. And he convinced me to join Kuka. For a year, I built out an office in Austin, which was a little premature in its mission, I would say, which was connect fleets of robots and warehouse logistics vehicles to the cloud. This was in 2015. And use AI to optimize small-scale industrial processes with small data sets. And if you know a little bit about AI, words like small scale and small data sets, not so good. So we built out the bones of starting to do that. And then I had the opportunity to move to Germany with my family and become the CTO of the Kuka group. And Kuka, I think I might have mentioned it, but they're not that well known, but they're like the fourth largest industrial robot company on the planet. In some television commercials and stuff, you'll see like these giant orange robots moving around tons of metal really fast. Those are Kuka robots. And while there, I looked at the digital strategy of Kuka overall. Again, and thematically, it was this, hey, robots are hard to program. Can't we create higher levels of abstraction to make programming robots easier? What I find truly funny, and I think it is truly funny, and it sort of says something about robotics. If you look at what you can do in Lego Mindstorms, it actually does as much or more than in most industrial robot platforms. It's actually more flexible in some ways because you're just dealing with so much variability. And really, for good reasons and some antiquated reasons, the industrial platforms are really locked down in specific ways that they work. And so I don't think that that's a real software requirement, but if you learn to program with Lego robots, you actually are probably dealing with a tad more complexity than programming an industrial robot, which I find deliciously ironic. And to your point about like inspiration, if you're satisfied like that, that's a moment I think everyone should experience, which is I write a software program. It's this digital abstraction on my screen. And when I run it, this physical thing in my real world moves. Like that is like first time I ever saw that happen. You're just like, oh my goodness, this is so powerful. So I got to live that in spades at Kuka because their robots are amazing, super high quality, globally ubiquitous. And I got to the joy of trying to create additional abstractions in the industrial space. And again, in a little teaser to where I think things are headed and what we're doing with artificial and related to the AI for good panel that you were on, Kuka was looking at what we'll call semantic programming of robotic systems, which really just means, hey, can I use reasonable natural language to instruct a robot system to do something? And what I find so funny, pre-chat GPT, my statement, hey, let's use natural language about the real world and what's in front of me to interpret what's happening and create a right set of semantic instructions. That was an amazingly rich, deep, highly complex, futuristic thought. Ooh, that sounds fancy. And it's like, tell the robot to pick up the coffee cup, use a vision system, a semantic analyzer, understand the coffee cup, how to approach it physically and do all this stuff. That was crazy talk. And as time passed, it became less and less crazy. And now with post-chat GPT era, me telling you, hey, we're going to use natural language to semantically interpret a scene and you'll get like a reasonable response back. Everyone's like, yeah, sure, whatever. I've seen demos of that now, like, constantly. But where we are as a society in terms of inhaling the AI is the large language models were an explosion. Let's view them as in a positive way. They were a catalyst as opposed to a tsunami. And there'll be a couple of years of companies like mine and many, many others across many domains connecting the AIs into the functional systems in various domains. And so we're doing it in the life sciences. I know people and friends are doing it in the construction space. Every field is doing it. And the implications of a LLM attached to an automated system or a tool set, we don't know yet, right?
Your life span is just so fascinating, right? I mean, and you're right. Kuka is just everywhere. And in fact, I was with the chief innovation officer who was the fellow judge, and as we were wandering the floor, she was saying people are pointing out different Kuka robots which are in the displays, right? So,
was that Ulrika Tagschier?
Yeah,
yeah, she's great. We overlapped briefly by a couple of years.
Well, it's just your history is just amazing. Now, so I could see your journey, right? From your father to experimenting to doing, really, really fundamental basic stuff where there's no meta layers, there's no abstract. You have to really do it at like bare bones hardware level stuff, and then you're building layers of abstraction to something like the Mindstorm, which is like really famous, right? And then the Kuka robots, which are really famous, and you're making things, and you're pioneering this idea of semantic, interflow, and being sort of a catalyst for all of that. But you were looking for that elusive CEO position. So is that why you formed Artificial as well? And I know some of your team and I went to Artificial, right?
Yeah, that's right, for sure. Yeah, so it's another major inflection point. So in 2018, Kuka was acquired by a very large Chinese entity called Midea. I might be mispronouncing it, Midea. So they're based in southern China in Guangzhou. That was a very, good business deal for Kuka. I would say I was getting towards the end of my contract. That was another thing I quite loved about German employment is, this is a little non sequitur, but I've always lived with this sort of imposter syndrome and fear, no matter what. I just can't get it out of my DNA. And so I would literally be, having a very successful career at National Instruments, and I would more or less walk into work each day and go, man, I think I'm going to get fired. Right? It's like, I don't know why. It was like from the beginning of the career to the end of it there, and at other places. In Germany, they have like very explicit contracts with extremely long exit times. And so like, wow, I have like a 3-year protected guarantee with a year of like, no matter what happens, I have a year. It was like the most stabilizing, calming experience for me in a professional context. I guess that says a little bit about me, but it was amazing. And so after the acquisition by Midea, and I was close to the end of that contract, I was really trying to figure out, do I stay in Europe with my family? My kids were in high school. They wanted to move back to the US. What do we do? And so I had met a venture capitalist named Peter Barrett from Playground.global, based out of Palo Alto. In several different contexts, as the CTO, I was screening a lot of startups for either investment or acquisition. And I was sort of looking at, what are the right robotics plays, for us strategically. And I kept running into Peter, and we were sort of always looking at the same companies. And we kind of connected, and it was like, oh, look, we have the same taste in technology. I put it that way. And so then we looked at, how Kuka might collaborate with some of the startups that he had. But he became a contact where it was like, we kept talking back and forth. And he sort of, I think, correctly identified that, I had scaled the ladder that I had so aggressively wanted to pursue my whole life, which was I want to control a company. I want to have influence. I want to be able to see if my intuitions about technology and business yield fruit, with unencumbered by other people's points of view, which wasn't necessarily bad. It was just like I wanted to see what happens if I did it. And I had kind of gotten there at Kuka. And, Kuka's a large organization. It's like 16,000 people at the time. I forget how many thousands of people I was managing. I sat on a board. I think the Kuka entity itself had like, maybe it was a very German construction, like 18 board members, a lot of union involvement. And one day I was basically sitting there in Europe. I had just had a bunch of board meetings. I'm having union calls. I'm negotiating labor stuff between Germany and Hungary. And I'm like, this is very, very far away from playing around with CPM to get it to work to play a computer game. That is something I loved. It's like, I kind of got what I wanted, but it wasn't satisfying, from a purpose point of view. And so to your question, like why found a company, why be CEO? It was really more about getting back to direct personal purpose at a fundamental technology and creation level than it was about wanting to be the CEO. Like at this point in my life, I absolutely just want to work on something I believe in. It has a purpose I like. And there's a direct value creation that I can still contribute. And there are people that, naturally feel good about the layers of indirection of being an executive or management, and they can take happiness and direct joy from organizing a well-structured company and running it. And I get all of that, but I still like to write code, and I get the most joy out of that. And so I know as I scale the company up again, I get further and further away from that, which is totally okay. But it was a beautiful, at the time, reset in 2019 to exit sort of large-scale multinational executive leadership and move back to, 3 people sitting in their houses with a piece of code trying to build an idea from nothing. That was awesome.
Yeah, I mean, that's, and you're getting traction. So now the audience isn't familiar with artificial. So can you talk about what your business model is? And my audience is really broad, by the way. There are CEOs out there, to scientists, to software developers. It kind of runs the gamut. Though because of just the nature of the work I do, it tends to be sort of heavy loaded on the CEO investor side. But there are the technical kind of people in there as well. So you got to build that meta layer, the abstraction when you're communicating with your company does. So what does artificial do, and why should people engage?
Sure, absolutely. So artificial is a software platform for running research labs. I hope that's sufficiently simplistic, direct. We really look at how do we digitize a lab, and how can we make a lab more efficient? How can we make it so that scientists get the most value out of the work they're doing in the lab? And it's a whole host of very basic and fundamental issues. Most scientific experiments done in a lab aren't repeatable. Most of them have limited data that describes what has happened with them, and they're prone to error. And they're definitely not portable across labs. And so these are sort of basic things like not reproducible, highly unreliable, and don't have really nice data sets. And so there's something like 60%, I'll mangle the statistic, but 60 to 80% of published papers have experimentation in them that's not repeatable by a third party. And there's a little bit of nuance in it, but I'll gloss over it for a second. But, we founded the company and its real focus in October of 2019, which was, just a couple of months before COVID, kind of flew across the planet. And we were looking at, not surprisingly, how can I create better ways for scientists to automate lab experiments? And it was around some of the themes that we've already been talking about. So can I use natural language? How do I make it really easy for a scientist to do this so that they want to do it and get reliable, repeatable results? And then I watched a series of papers published by the different national health agencies, all on how to do a COVID test. And so the first question I had is, why do we need 19 different health agencies to develop 19 different tests? And then the other comment was, I went and downloaded all the papers and read them. And the first publication by US was this beautiful, well-written, perfect English legal document up front, very, rigorously beautiful scientific language. And the experiment itself was invalid. There was a flaw. And there was this, and I hate to use the term, there was this really butchered English-German paper written by a German health agency that was sort of brutalistically direct, not full of legalese, and it worked just fine. And so there was one from Thai, so there was a bunch of these different things, but it actually speaks to a fundamental flaw that artificial is seeking to address in the way that the world does scientific experimentation. We don't have a way to describe the work and share it so that it's repeatable across labs. Like, that's a pretty big problem. In my envisioned future, the first group that takes some lab equipment and runs a diagnostic test and describes it with our tools could publish that, and then someone else could download it, map it to their hardware, and run it. There's some nuance about how portable you can really make it based off reagents and specific science I don't get into. Yes, that what I'm describing is a very audacious goal, but there's a lot of science that we can make more portable, more digital. So to your question, fundamentally, we sell to research labs to digitize their lab, to make their scientists more efficient. And with the recent advent of the LLMs, we have the digital structure to connect the data, which an LLM needs, to action, which the LLM also needs. So that the real vision pursuit that we're doing with companies like Moderna and others is, how can I have an AI-driven research lab? And the precondition for that statement is, I've digitized my lab, which has value by itself.
That's really fascinating. I mean, I've just, so are you talking to Michael Langer and Bob Langer and the Terasek Institute? I'm just sort of brainstorming with you. Or there's a gentleman named Alan Shatrid. He's a serial entrepreneur. He's a past president of YPO Gold International, YPO being this private CEO community, but he's got this thing called Lab Connect. It sounds like you'd be perfect for what he's trying to do. So I'm happy to do introductions if you're not connected.
Yeah, I am not talking to them. I would love to talk to them. Yeah, no, I think there has been several other companies, particularly with the advent of the LLM, who are latching on to the let's digitize these labs. There are, and some of these are part of massive initiatives of the hyperscalers. So, we're a small, scrappy startup. We've been at it for a while, and I think we have some technologically strong differentiation and some viewpoints that are built out of this history. We've been talking about abstractions that scale. But, this moment right now, so people like Lab Connect, people like us, others, the value of the digital payload in and out of the lab has just exploded. And so there's sort of like the nuts and bolts of running experimentation and digitizing science. And then there's the hyperscalers like NVIDIA and Microsoft and Amazon, who are, for good and bad, are essentially looking at all the data sets on the planet and which ones are the most valuable and have the highest impact, and how can we get access to those data sets to create foundational models, right? So Google, has been out in front with DeepMind and AlphaFold and all of the protein folding stuff in the life sciences. But NVIDIA is partnering with so many life sciences companies to get so much data out of these labs to create foundational models. And so there is this mega trend that we're a part of, where the value of the standardized view of all of this data in the life sciences has exploded tremendously because of both LLMs and our ability to create foundational models. And so everyone is chasing, okay, what's the next life sciences model where I can have a trained AI that fundamentally changes the way we do drug discovery? And I think anyone and everyone that's in this space is benefiting from that. And I think it will from a mission point of view and a purpose point of view, it's fantastic to be a part of. We're probably, we've seen the benefits already with protein folding. What's next from quantum to AI, it's going to be phenomenal.
I mean, you're working with Microsoft to a certain extent. I mean, are you also leveraging Microsoft Azure quantum elements, or is that something sort of outside of what you plan to do in terms of your cloud-ready lab orchestration? You're trying to provide some kind of stability in terms of how things are repeatable within the lab environment, and maybe create a little bit of standardization in a way through your software stack, right? I mean, I could see all the benefits. Are you leveraging maybe connectivity to some of these other things that are out there from people like Microsoft, or is that another space that you're not getting into?
Microsoft itself has such a broad platform. By definition, yes, I'm leveraging it. I would say, Microsoft was our lead investor in our Series A. Ironically, we had started out on Amazon as our core platform. We've migrated to Azure, and that served us super well, both from a standardization and rigor of IT auditing. So some things for compliance and regulated markets, Microsoft is extremely strong. So at the core compute level, the storage level, the sort of rigor of compliance and security, that's all on Azure, and we're absolutely leveraging it. Literally before this call, I was looking at our AI strategy, and we'll be using Azure AI Cognitive Search, which is rebranded as Azure AI Search, plus Azure's hosting of OpenAI, and that'll be an integral part of how we bring the digital context we've created with our customers into the AI loop, and that implicit connection of the data in the lab to the services offered by OpenAI and Microsoft in general in the AI space. We're making that connection seamless. So from my view, specific answer, yes, we're massively leveraging the Microsoft general, more horizontal platform offerings, particularly around AI. And really, this comes all the way back to the abstraction and ease of use problem. The number of scientists in different research labs, from small scale to very large, that have the background, interest, and time to completely digitize their lab, standardize the way work happens, structure the data, implicitly connect it to an AI pipeline, and then bring that back around is very small. There are a few companies that are trying to build these stacks themselves in-house, but we view our primary value proposition is fundamental digitization with the added benefit now of tight contextual integration of the AI. In the end, that means the scientist basically just has better tools to do their research.
Yeah, I mean, I could think off the top of my head just so many different groups that would really be where this will benefit. So I'll definitely share this interview with them and then do connections and so on. I mean, clearly there's a gap in the marketplace, and you're filling it, and you definitely have the background in industrial automation and making things easier in software. And it's interesting, after this sort of wonderful career you have, you want to get back to the nuts and bolts. That's really
Right.
fascinating, right? So,
No, it's a journey of self-discovery. It's like, where is your true implicit passion? And then, frankly, I've been lucky enough to get to the point financially where I'm not chasing the executive path just because I want to chase the path for control or money or whatever. I want to have a purposeful application of my technology. The startup phase is actually perfect for me personally at this point in my life, because it's a blend of everybody has to, we're like 21 people. And so, my head of customer success also has to do marketing and does some sales and things like that. So I love the hands-on nature, and I feel privileged to have the at-scale executive background and organizational understanding and the dynamics of people and all of, the executive talk. But I really love what I get to do every day, which is wake up, work with amazing customers, and again, not to be negative on any specific market, but, waking up in the morning and figuring out how you can shave 30 milliseconds off the production of a Jeep car body versus waking up and saying, how can I standardize science so Moderna can do drug discovery better? They're very different, like, internal motivations for me. And so if I take that and combine it with, let's build out an organization, let's build a business, and let's build a technical stack at a fundamental level from the ground up, it's been amazing. It's also been humbling. And certainly when I look back at companies like NI, I took for granted as an 18-year-old coming out of school, high functioning marketing, high functioning sales, and high functioning technology all in one company. And it was the only place I knew. And so for me, to your point, it's about purpose, it's about hands-on technology, and it's about delivering for our customers. And those three things together is what I get to do as the CEO of a small company. And it's highly rewarding.
Yeah, I mean, I could see that. I can see, you're smiling, and I can feel the joy in what you're doing now, and it has this enormous catalytic kind of multiplier impact, right? Because you're getting into foundational work in powering what labs are doing, right? And really allowing them to scale in a thoughtful way and have it repeated as well, which is a big gap in the marketplace which you're addressing. So I'm going to sort of now swing the interview in another direction, and that's trends. So we talked about, this thing that dropped in November of 2022, and it kind of shook the world, right? And then you see all of these companies really betting on this. But then you have people like Jan LeCun saying, well, LLMs are not enough. You really need something that's a little bit more hybrid, maybe something like neuro-symbolic or something like that, but something hybrid. So LLMs are not enough. But then there's Jeffrey Hinton earlier this year at Oxford was saying, I was thinking this was 20 years out, or I don't want to paraphrase. I just encourage the audience to take a look. But my sense is he's saying, I thought this was going to be way in the future. It's not. And it's remarkable, and we have to think about this in a really thoughtful way. And then I see this paper dropped early this year where they used random graph theory to kind of see, can we kind of make sense of what's happening in LLMs? And then they find that it's like gaining skills and it's configuring them in novel ways. So there's a lot more going on. And that means that so I guess, which camp are you? Are we at this major inflection point as a great augmentation for us? Or do you think it's still far out? 10 years out, or do you think it's under 5 years? And some people are saying next year, right? So,
right. It's a fairly loaded question that's been debated even pre-LLM, in the pursuit of AGI and all of this other stuff. I believe that we have hit a massive inflection point. It is a massive inflection point. Is it an inflection point where, we've achieved Star Trek AGI and, we have a thoughtful, evolving companion and blah, blah, blah? I don't think so. But that doesn't mean that what was accomplished isn't phenomenal and world-changing. So I believe that what they accomplished with OpenAI and all of the follow-on LLM methodologies at scale and our ability to create foundational models, to LeCun's point, to augment them, is ground-changing. And when I said earlier, I want to be positive and say it's a catalytic inflection point for creativity, I think that's true. I also view it as a tsunami where the LLM imploded in the deep waters, and everybody taking the power of that LLM and harnessing it into their tools is what's happening right now. So we don't know what a well-integrated LLM deployed in PowerPoint and Word and Excel and AutoCAD and every creative tool on the planet looks like at maturity. Like we know what it looks like where we've done some co-piloting, quick and dirty experiments that generate some stuff, and we're blown away by that. So imagine 2 to 3 years from now, where Autodesk has fully integrated generative technologies into the design flow of an architect. I have friends that are running companies both in some weird niche spaces like 3D printing of homes and concrete to more direct, like let's augment AutoCAD. And my wife's an architect, where you can take an AutoCAD drawing, say, I'm trying to build this home in Austin, Texas. Please take the Austin, Texas regulatory codes and this design, or is it compliant? And so that's going to remove and augment and accelerate several jobs, but it's going to make our, certain things more efficient and certain jobs go away. That's just like one domain. So the trend of LLMs being transformative, driving fundamental workflows across multiple industries, raising productivity, that is going to happen in less than 5 years, and it's going to completely transform the employment landscape. And there will be winners and losers, and it will be broad-based. And so that's going to have very positive productivity benefits. And there's going to be potential, need for people to find different ways to leverage that productivity, which is, the human condition when new tools are released onto the planet. I go back and forth on this topic, but, no one ever really gets upset that we have, bulldozers to remove dirt, and are saying things like, let's all use shovels instead because that creates more jobs. So, we will adapt, but I think it's transformative, and I think there will be multiple industries that are fundamentally altered in the nature of their labor. I'll stop.
I sat a private workshop with PwC there, and was it's really fascinating, the data that they're compiling and the impact it's going to have. And I actually told them at this roundtable that I think it's going to be faster, what your data indicates, because I deal with CEOs and I get to see what they're thinking in terms of adoption of this and how they want to integrate it in some way. But it's not just that, and we don't have time for this, but there's like quantum computing scaling and niche applications, but getting closer to this universal concept, and it's biomedical innovation, and just the whole medical space is just really transforming. It's this chip technology. It's there's so many of these confluence items that are converging, and it's interesting. It's happening real time now. So. But I have one more question, and that is...
Before you jump to the last question, you did throw some red meat in the water, so I have to at least respond. That confluence that you mentioned, that one, so I think that there are elements of it that are going to happen really fast. So I think the confluence of AI, compute, and the wet lab, that's basically what I'm chasing, as are many others. And so that's what's happening now. It'll fundamentally change the way we do drug discovery, the way we do cell and gene therapies. And even that is a confluence of, hey, CRISPR and the ability to edit genes and, personalized medicine, that's also all new and crazy and awesome. And so you take that and combine it with the AI and the compute, and, that's the mix that we're all playing in right now that I love. Like, we're getting so much creativity and value on the planet, and about healthcare and life is going to come out of that. You take that and then you inject some quantum into the mix, and it's another further confluence. It's a little further out, I think, but, I saw a great fundamental talk at South by Southwest on quantum. And essentially, quantum is good at modeling quantum systems. It's about really its fundamental purpose. And the most useful quantum system we can manipulate is chemical and chemistry and material properties. So our ability to take quantum, model quantum systems for drug discovery in cells and molecules, combined with the compute and the AI and the automation, is going to be amazing. We're not there yet, but it's coming.
Yeah, I mean, and we're living it. Right? So, and you're having an impact on it. Like, you're contributing in a fundamental way to the world. So, I applaud you for just this marvelous work you're doing. Just one final question. Do you have a recommendation or questions you want to leave the audience?
So it's a great question. I'll fundamentally make a recommendation as the CEO of a startup in the life sciences space. My recommendation is for anyone in the pharma, drug discovery, early phase R&D, and even in manufacturing who's looking to improve their tech transfer is fundamentally find partners to help you digitize your stack, connect and ride the waves of AI and quantum, and we'd love to partner with you to do it. I hate to be self-serving in my recommendation, but I'm going to be.
Well, that's a great recommendation. I mean, with your background and what you try to do, it's going to make the world better, right? So David, thank you for coming in, and just love this interview with you. You're just an amazing person and contributor to the betterment of all and to all Earth ecosystems, and in parallel. In essence, that's the kind of way I see you fundamentally contributing, and I really appreciate you sharing your insights with our audience.
Yeah, this has been great. You're a fantastically genuine facilitator, so it's been a pleasure.
Thank you for listening to the Brand Called You videocast and podcast, a platform that brings you knowledge, experience, and wisdom of hundreds of successful individuals from around the world. Do visit our website www.tbcy.in to watch and listen to the stories of many more individuals. You can also follow us on YouTube, Facebook, Instagram, and Twitter. Just search for the Brand Called You.